Going to appreciate that. So just remember, learn from your mistakes if you made them. So you have a rectangular shape, length is 15, width is 2. So I do give you the information as to the dimensions of it. A new rectangle is created using a scale factor of 3/2. Okay. So what do we know? Well, it's an increase. We know that for sure, because k is greater than 1. So just by observation, you already know that. State the scale factor as a percentage. No problem. We simply say k is 3/2 times 100. That's 150%. I think you got that. Calculate the new length. So this is where it's up to you how you did it. But remember, when you go from the original to the new, we multiply, correct? So whether you set up a proportion or you just go length of new, is simply taking the 15 centimeters, multiplying by the scale factor, okay? And you get 22.5, I believe, yeah, 22.5 centimeters, 1 mark for that. So everything gets 1 mark unless I tell you otherwise. Calculate the new width. So the width of the new, I'm gonna do this differently, okay? So watch this. If you set up the proportion, right, k is equal to width of new over width of original, which is 2 centimeters. Okay? If you have it like that, and you cross multiply and divide, you get 3 centimeters. 2 times 3 divided by 2, the 2's cancel, and that's 3 centimeters. So you get a mark for that as well. So whether you set up a proportion, whatever you want to do, it all jives. It all is connected. How much greater will the new area be? And the answer is, I don't know if you weren't sure, it's k squared times bigger. So it's 3/2 squared, so that'll be 9/4 times. Okay. How much greater will the new volume be? You go k cubed, so that's 3/2 cubed. So that'd be 27/8 times, or you can do decimals, it's up to you. Okay. I know something here that is probably confused you. How does a shape that only has length and width, how does that have volume? Sorry, I didn't think this through. I should have given you a height to this as well. But if you were to use this as your base and give it some sort of height, it doesn't matter what it is. The volumes, like this is how this would be the ratio between their volumes. Regardless of how you approach it, that's what would happen. It doesn't matter what the height would have been. This is it. Okay. So 1 mark. 1 mark for all these. If you did them as a decimal, that's fine. The 9/4 is 2.25. And the volume is 3.375. That's okay as well. I'm okay with that. 500 kilometers represented by 2.5 centimeters on the map. Use a scale, right? State the scale, sorry, that is used for this map. And remember, I want to use diagram and actual if I have a map or a picture of some sort. So you go 2.5 centimeters to 500 kilometers. Different units are right, but decimals aren't. I don't know if I showed you, so I'm going to give you the marks here already if you got this. But you know how there's 1 decimal there? So you go look for the greatest number of decimal places and you multiply it by either 10 in this case or 100, whatever you need to do. So this would be 25 centimeters to 5,000 kilometers. That is okay. Okay, so basically what we did here is we went times 10. We multiplied this entire scale by 10 to get this, to get rid of decimals. No decimals, okay? 7, if 2 towns on the map are 8.1 centimeters apart, calculate their actual distance. I know space is very limited here, but basically what I will do is I will use the scale, this one. It doesn't matter which one you want to use. 2.5 centimeters diagram goes on top, 500 kilometers goes at the bottom. Okay, so the 8.1 centimeters would be here, and this is your unknown. Okay, so you cross multiply and divide, and to be honest, you may have approached this a different way. I'm okay with that. So you get 1620, right? 1620 kilometers on the actual, that would be the actual distance that corresponds with a 8.1 centimeter stretch on the map. So if you get this number, you get the mark. There's no way around that. So this is 7. I'm just going to make a note here. That's 7. For 8, it's just asking it differently. If the towns are actually this far apart, what would it be on the map? So you start with this one again, 2.5 centimeters over 500 kilometers. You don't know that, but you do know this, which is 360. You set up a proportion, right? So it's cross, multiply, and divide. So x is 2.5 times 360 divided by 500. And that would be 1.8 centimeters. So if you get that, you get another mark there for that. By the way, if you use 25 centimeters, 5,000 kilometers, you get the same answer. Right? So in this case, it doesn't matter which one you use. I should have asked for a scale factor, but I would have been pretty, you would have had to convert the kilometers to centimeters, which would have been quite a big number there. So 1 mark for each so far, okay? True or false? An object was enlarged by a scale factor of 3. This object's area would be 6 times greater than the original. And this is false, okay? It would be, yes, there you go, 9 times. And this one kind of gave it away. Maybe if you went back to 4 and 5, maybe this one helped you. True or false, an object was reduced by a scale factor of 3 over 4. We know that it's a reduction because it's less than 1. The new object's volume would be 9 over 16 times smaller. And the answer is false, because if you cube it, that's 27 over 64, right? Is it 60? Yeah, 64. So false. It would be this times smaller than the original. So 1 mark, 1 mark. If the original shape has an area of this much and the new area is this, what's the scale factor? Right? They want K. That's what they're asking for. What's K just by itself? You know we're using areas, right? So you go K squared, original, new. I go new over original, correct? It's always new over original. In this case, they use that terminology. Perfect. We reduce, or we get rid of the units. We square root both sides. And what do we get there? 11, that is 4. It's actually exactly 4. So I will give you 2 marks for this one. So make sure you make a note that this is worth 2. I'll probably do that right here, because you need to first put them in the right order and you need to square root. That's what I'm going by. If the original volume of an object is this and the new is that, what's the scale factor? We're dealing with cubed units, and we want new over original. Oops. Meters, not centimeters, sorry. Get your act together, right? Boom. We cube root, so you got to make sure you indicate that it's a cube root. Did I show you how to cube root on your calculator? I hope so. I think I did. Here it is, in case you were sleeping or something. Yes, math 4. So you can, this is how you could technically do this. Math 4, and then use brackets like this, you could actually type in exactly what you have on there as long as you use brackets. And that is your, we could do this, I'm not asking for it, but either one of them. And you could probably turn that into a 1, right? 1 or 3. Does math 1 do the trick? Yeah, it does. So if you didn't realize that it is 1/3. Okay. You don't have to have it in the 3 formats because I did not ask for it. Either one, like whichever one is good. Also worth 2 marks because you have the cube root. State a value of k that would result in a reduction. Anything you want. 0.2, 7 over 8, right? 0.999, 95.29%. So you choose which format you want to use as long as it's less than 1 or less than 100%. And 14 and 15, you don't know that yet. So sometimes I mix up the order of my units, or I change it because of, you know, I kind of try to find the best way to go about the order to fit like winter break and all those things, all the holidays. And so just ignore those. I hope you didn't lose sleep over those. Anybody Google that? Why would I do that? No. So don't worry about those. Okay. So how many marks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is going to be out of 15. Just make sure your name and last name is on there. Actually, last name helps me a great deal because when I enter it into my spreadsheet, it's arranged by your last name. Okay? So that would be great. Thank you.